Liquid water may still flow on Mars, but that doesn't mean it's easy to spot. The search for water on the red planet has taken more than 15 years to turn up definitive signs that liquid flows on the surface today. In the past, however, rivers and oceans may have covered the land. Where did all of the liquid water go? Why? How much of it still remains? Observations of the red planet indicate that rivers and oceans may have been prominent features in its early history. Billions of years ago, Mars was a warm and wet world that could have supported microbial life in some regions. But the planet is smaller than Earth, with less gravity and a thinner atmosphere. Over time, as liquid water evaporated, more and more of it escaped into space, allowing less to fall back to the surface of the planet. Where is the water today? Liquid water appears to flow from some steep, relatively warm slopes on the Martian surface. Features known as recurring slope linii, RSL, were first identified in 2011 in images taken by the High-Resolution Imaging Science Experiment, HI-RISE, camera aboard the Mars Reconnaissance Orbiter, MRO. The dark streaks, which appear seasonally, were confirmed to be signs of salty water running on the surface of the planet. If this is correct, then RSL on Mars may represent the surface expression of a far more significant ongoing drainage system on steep slopes in the mid-latitudes, a research team member told Space.com in 2012. In 2015, spectral analysis of RSL led scientists to conclude they are caused by salty liquid water. The detection of hydrated salts on these slopes means that water plays a vital role in the formation of these streaks, the study's lead author, Lojendra Ahuja, of the Georgia Institute of Technology in Atlanta, said in a statement. Vast deposits of water appear to be trapped within the ice caps at the north and south poles of the planet. Each summer, as temperatures increase, the caps shrink slightly as their contents skip straight from solid to gas form, but in the winter, cooler temperatures cause them to grow to latitudes as low as 45 degrees, or halfway to the equator. The caps are an average of 2 miles, 3 kilometers, thick and, if completely melted, could cover the Martian surface with about 18 feet, 5.6 meters, of water. Frozen water also lies beneath the surface. Scientists discovered a slab of ice as large as California and Texas combined in the region between the equator and North Pole of the red planet. The presence of subsurface water has long been suspected but required the appearance of strange layered craters to confirm. Other regions of the planet may contain frozen water, as well. Some high-latitude regions seem to boast patterned ground shapes that may have formed as permafrost in the soil freezes and thaws over time. The European Space Agency's Mars Express spacecraft captured images of sheets of ice in the cooler, shadowed bottoms of craters, which suggests that liquid water can pool under appropriate conditions. Other craters identified by NASA's Mars Reconnaissance Orbiter show similar pooling. Evidence for water on Mars first came to light in 2000, with the appearance of gullies that suggested a liquid origin. Their formation has been hotly debated over the ensuing years. But not everyone thinks that Mars contains water today. New research reveals that RSL may actually have formed by granular flows formed by the movement of sand and dust. We've thought of RSL as possible liquid water flows, but the slopes are more like what we expect for dry sand, lead author Colin Dundas said in a statement. This new understanding of RLS supports other evidence that shows that Mars today is very dry.